Okay, in the next few sessions, we're going to have a brief review of time series. Now, may I ask you guys, who among you are already familiar with modeling using ARIMA and let's say modeling volatility in GARCH? First, let's start with the modeling a time series using ARIMA. Could I have your feedback, guys, if you're already knowledgeable about this? Yes or no, please? Okay, good, good. Even those who were my students, were you my student? I think many of you were my students in FinSAR. Okay, did we fail to discuss that in FinSAR? Okay, anyway, that's good, guys. That's good because this will so not only a review. This will be a new lesson for everyone, since most of you have not had a discussion on ARIMA. Okay, so when I prepared this, I was thinking that all of you already had a background in ARIMA, so that's why I did not put so many details about it. So anyway, let's just discuss while we go as we go on with the lesson. Okay, so we're going to discuss time series in the next few sessions, and we're going to learn several models in time series, not only autoregressive moving average, but we're also going to look at modeling volatility. Okay, we're going to do multivariate time series, so we're going to learn vector autoregression, vector error correction model. Okay, so some of the more advanced stuff in time series. And if you recall, guys, I said in the first session that we had, we're going to, towards the end, we're going to do machine learning. I'm actually excited about that. I'm very excited about deep learning and machine learning. We're going to use both R and Python in this class. So, but let's take things in stride, one lesson at a time. Okay. So the library, the packages that we're going to need are forecast, FPP3, quant mode we met last time, time series, T series, and the time series XTS also. ggplot2 is for data visualization. Urca is used for GARCH. Okay, Plotly and GG45 is more for data visualization or plotting. Okay. Now, in case you haven't installed this in your machine, make sure that you maybe just use the console window to type library, install the packages. Okay, diba? You know this, diba? Install the packages, and then forecast. So this is how you install packages in R. Install that packages, then forecast, and etc. Okay, so I'll give you a few minutes, guys, to install the packages in case you don't have them yet. One way to find out is if you run these packages, and you'll get a message that it does not exist in your machine, then you'll have to install it first before you can use that package. So let me first pause recording of our session. And then if you're done, guys, with the installation of the packages and also with the accessing of the package, then please chat, write in the chat box, yes or installed already. Okay, so that I know if you have already done so. Okay, so let's pause for a while and I'll ask you to do those things first. Okay, so let's proceed, guys, with the my apologies. I should have actually what I gave you was my copy. I should have given you the blank copy so that you'll be the one to type the codes, guys. But I I forgot to do it. What I gave you was a copy that already has the code. So next time I have to be more careful. Okay, we're going to make use of the air passengers data. Okay, R usually includes with it data sets that can be used in statistical analysis, one of which is the air passengers. Okay, if we check, for example, okay, strongly recommended. Okay, do you want to restart? Okay, no na muna. Okay. Ako pa pala guys yung may problem sa installation. Hindi ko ina-install kanina. Anyway guys, sige. While this will not run kasi ano pa siya, nagra-run pa siya. No? Now, yung air passengers data, if we run this, so I have to wait. Okay. So were you able to access this data, air passengers? It comes with R. Okay, so we can access this. Kindly chat, class, if you were able to access the data, air passengers. Please type in the chat box. Okay, good. Okay, thank you. Now the packages are there. Okay, okay now. So the packages have already been installed. Okay, data, air passengers. Now, notice guys, when you access data air passengers, what happens is that it's still in the value. In the values, it's not still part of the object in the data set data. Okay, so in order for us to access this, we can use the in this. Okay, here first. In this, we change the name of the data. We change it into AP because it's a long name, air passengers. So we're just assigning the name AP for ease of use. So let's run this. Okay, and take note, there's another value here, AP. Okay, if you want to see the data itself, okay, we run this code view. Okay, the view code will allow us to see the data as a tab here in our markdown, our studio. So if we run view, then automatically we now have an object AP, and then it gives us the data, 144 all in all. Okay, 144 all in all. If we want to learn more about where this data is coming from, okay, let's try to air passengers. Let's try to get the help function of Excel of R. So question mark air passengers, control enter. Okay, so this data set comes from the package data sets. So there's a package called data sets, and it contains different types of data sets, and one of which is monthly airline passenger. So this is from 1949 to 1960. So this is actual data. This was used in the by Bucks Jenkins, who authored the ARIMA model. These are monthly totals of international flights from 1949 to 1960. Okay, so monthly time series in thousands. If you want to learn more about the specifics of this, okay. So here we have some codes. This is all about ARIMA, which we're going to learn later. Okay, so it's a monthly data set from 1949 to 1960 of international air passengers. Okay, and the values are in thousands. Okay, so that's our data set, guys. Okay, and if we want to see the class of this data set, okay, what's a class of this data set? It's a time series. It's a time series plot. Okay, TS stands for time series, which means that the observations are ordered. Okay, so chronological yan, ano? So it's not a cross-sectional data where the observations can be ordered at random. Here we cannot randomize the ordering of this because time series data are arranged logically by time. Okay, so we have a time series data, these air passengers. And next, okay, let's try to see if there are missing values. And let's try to learn more about the data by looking at the frequency, the cycle, and some summary stats about the data. Okay, so AP, we have the AP data already here. Okay, in fact, it's already here. Then this function sum is an A of AP. It tells us first to look at the missing values of our data AP and then sum them up. Okay, are there missing values? We know that there are 144 observations for this time series from 1949 to 1961. That's 12 years. Okay, 1949 to 1961, 12 years, and 12 months each. So 12 times 12, that's 141. 144. Okay. So if we want to know how many missing data there is, we can use this function sum, okay, is NA AP. So this will read first is NA, okay, and then sum all the incidences of NA of missing values. Okay, then it returns the answer 0, which means there's no missing value. That's good. Frequency, okay, what's frequency? 12, which means that this is monthly data. If you're interested, guys, okay, let's take a look at frequency. So frequency, okay. So sampling time series, this is from the stats package. Okay. So stats package, and then frequency returns the number of samples per unit of time. Okay, the time interval between the observations. So this data set, air passengers, we'd like to know what's the interval between per unit time. Okay, so it tells us that this is 12, which indicates that this is monthly data. Okay, per unit time. So for the first time unit, 1 to 12. So that's 1949 up to 1961. Okay. How about the cycle, guys? Cycle. Okay, so it gives us, guys, the plot of 1949. So this is for 1949. Okay, so this is 1960. So all the January, guys, are identified as 1. February is 2. Until December is 12. So that's by month. By month. And then summary, guys, gives us some summary statistics. Summary of our AP. So gives us the 6-number summary. The minimum number for the whole series, time series, is 104. So 104, is it thousands or millions? I forgot. 104 passengers, 104,000 or 104 million passengers minimum. The maximum was 622 million passengers. Okay, the average of the whole series was 280.3, and the median, the middle point, is 265. And this tells us that this is quite skewed to the right. The mean is to the right of the median. Okay. All right. Any questions so far, guys? To be honest with you guys, we were supposed to write this code. Okay, we were supposed to go through this together, and then what I gave you was the wrong file, the file with the codes already. Okay, let me pause for a while. Any questions so far as regards our data set, the air passengers? we found that there was no missing data. This is monthly data from 1949 to it should be 1960. 1960. And then cycle, January are termed as 1, December are termed as 12. And then we can find here that the maximum number of passengers was 622 million. The minimum was 104. Okay, any questions, guys? Kindly chat in the chat box, guys, if it's clear so far. Okay, good. Good. Thank you so much. Thank you so much, guys. All right, so let's go back. Let's now go to, let's continue our codes, okay? We can use the base R function plot, or we can use the GG45. So this is related to GG plot 2. We can use the auto plot function, okay, of GG45. So let's take a look at the first plot. So we're creating an object called P1, okay? And then we're asking our plot the object AP, and then give a label, X label of date to your X-axis, give a label of passenger numbers in thousands to your Y-axis, okay? And then the main plot, give it a name, air passenger numbers from 1949 to 1960, and then generate the plot, P1. So this is what this code does, okay? It plots the object AP, gives it a label in the X-axis, a label in the Y-axis, and then label in the main object itself, in the main plot. So let's run this. Let's highlight this chunk of code. Control Enter, and then we have this plot. Okay, there. Okay. Okay, so let me just first copy this a bit. Okay, any questions, guys, with the plot so far? I don't know if I can, let me check. Okay, so let's analyze the plot a bit. So what can we say about the plot, guys? How is the plot of air passengers behaving? There are two things that are apparent here. Okay, what can we see here in the plot of the data? Okay, first, guys, do you notice that there's a trend? Di ba may trend siya, no? So the direction seems to be going up, no? So there seems to be an general upward direction, and we call that general direction movement, movement, guys, of your data. We call that your trend. That's our trend. So there seems to be a general trend of upward movement. It means that over time, air passengers seems to be increasing. And not only that, there seems to be, what we call these guys? We have here, there seem to be certain points where what do you call these guys? And also there are points here below. Diba? So there seem to be peaks, no? May mga peaks yung data natin, and there are also troughs, no? Yung lower point. Okay? And this is indicative that there seems to be what we call a seasonality, no? para may seasonality siya. Okay? So, parang dalawa nga yung seasonality, no? Una dito, tapos pangalawa dito. And that pattern is apparent. So we can guess, no? Since these are air passengers in thousands, either ito, guys, kasi ito yung end ng 1960, no? End ng 1960. So parang parang travel to, kung sa US to, parang either November to, no? Baka November. Holiday season siguro to. I think I could only surmise na Thanksgiving. So everyone seems to be going home. Okay, so meron din dito. May sub-peaks tayo dito. And if this is October, November, then this should be around July or June. So parang summer months, no? So we can say that there seems to be not only trend, definitely may trend siya kasi pataas siya, guys. And there seems to be a pattern, okay, where there are times when the air travel goes really up and then babagsak siya, no? Tapos merong secondary na mataas. Yan. If you notice, guys, a few months before yung peaks, merong sub-peaks. And as I said, I was guessing that if this is October or November, kasi at the end of 1960, parang December to eh. Okay, so after this peak, babagsak siya, ito, and then it will tend to go up. Okay, so that's how we look at this data. There seems to be a trend, and there seems to be a seasonality. No? Okay, so all right. Now we can use the GG45 package in order to plot this also. It will give us almost the same naman. No? So here we're creating a second plot P2. And then we're using this auto plot function. Okay. So once again, if we check, guys, auto plot, control enter. Okay. So auto plot function comes from, so marami siyang pinanggalingan, ano? Merong feasts, merong fable tools, merong ggplot, okay, merong forecast din. So this auto plot, it's coming from either ggplot2 or forecast, because those are the packages that we installed. Okay, so autoplot of the object AP, and then here's the label, labs, X is equal to date, Y is equal to passenger numbers, etc., and then the title. So mas smooth, guys, yung pag-coding nito, kasi dito separate pa yung X label, Y label, no? Tsaka may main pa. Dito under one code, one function labs, pwede natin ma-identify yung X, yung Y, at saka yung title mismo. Okay, so why don't we run this? And you see that it's almost the same as the first one. Okay, mas clean nga lang tong yung galing sa ggplot or the forecast package. Okay, it's a lot cleaner than the one coming from the base R package. Okay, any questions so far, guys? Clear naman tayo so far? Chat please, guys, kung clear tayo so far dun sa pag-plot natin using the base R plot or using the ggplot auto plot function. Okay, thank you. All right. So, moving on, guys. Now, pag may seasonality kasi, maganda yan, malaman natin yung we can check for the seasonality using the box plot function. Okay? So here we're creating an object called BP1, and then we're using the box plot function. Saan galing yung box plot function na yan? Okay? One way to know, guys, it's also important to know where these functions are coming from. So question mark, box plot, control enter, and then it will tell us that this is coming from the, isa lang ba siya? So it's coming from the graphics package. No? This produces a box and whisker plot. Okay. All right. Now, take note, did we install the graphics package? Hindi naman natin in-install yung graphics package, di ba? Right? But there are some packages that come with the base R. So ibig sabihin, pag in-install, naka-install na sa R sa atin, syempre hindi naman natin magagamit si R Studio kung wala tayong R. Ibig sabihin, naka-default na yon na nakasama na siya dun sa base R package. So even without installing this package, we can still use it despite the fact that we haven't installed it in our machine. Okay, so let's go back here. So here we're creating a box plot. This is coming from the graphics package. Sometimes, guys, if you want to be to know for certain kung saan galing yan, pwede yung ilagay yung namesake niya, no? Yung graphics. Just for you to be aware, because some would like to know saan bang galing tong box plot na function na to. So it's coming from the box, from the graphics package. Okay, and then the function is box plot. And then AP, all right? And then we have here the tilde, cycle ng AP, and then X lab, Y lab, and then the main, okay, parang pareho lang kanina, and then BP. Okay, so what we're saying here, when the graphics package plots this box plot, dapat gamitin niya yung cycle na, ano yung cycle natin? Monthly. So makikita natin yan, ang pag-plot niya to, monthly yung pag-plot niya. Okay, kasi we're asking R to plot the cycle of AP, which is monthly. So if we plot this, guys, to run this, okay, what do you find here? Okay, take note, guys, now 1 up to 12 siya. Okay, 1 up to 12. Ibig sabihin ito, what does this mean? Plot niya lahat ng January, February, March, April, May hanggang December. Okay. So what do we find here, guys? What do we find here? Makikita natin yung median. Median, this is the median, no? around 350. Okay? Pinakamalaking median is month ng July. Okay. Month ng July. Okay, medyo nagpipick siya. Ito yung maximum natin. No? July, then it goes down August, September, October, November, okay, medyo November yata yung pinakamababa, and then it will go up again January, come down on February, a little bit of March, April, May, June, then July. Okay, so paakyat dito, guys, no? Paakyat dito hanggang umabot siya dito sa peak. So most probably, guys, ang pinaka-peak natin dito yung July, no? And then bababa na naman. Okay, so this is how the use of the box plot allows us to understand more the seasonality of our data. Kasi we're asking R here to, when they plot the box plot, make use of the cycle of the object AP, which is monthly cycle. So here, kitang-kita natin, no, yung galaw ng ano, and yung pinaka-peak points natin, yung pinaka-mataas, it happens in July. Okay, July siya. Ano bang reason kung bakit mataas yung ano? Summer months ba yan sa US? Okay. Mukhang summer months, no? And then July, August, September, bababa siya ng ano ng towards the winter season. And then tataas na naman sa summer season, no? Okay. So clear, guys, so far dito sa box plot natin. Paki-chat, please. Okay, and also may I know, guys, if kamusta naman yung pace natin? Am I going too slow or tama lang ba yung pace? Feedback, please, guys. Kasi I can accelerate if you feel that tama lang. Okay, sige, thank you. Constant feedback sa akin, guys, kasi sometimes I might be going too fast. No? All right. So here are some explanations about the box plot. So let's just briefly go through this. Sabi natin, it's increasing over time each year. No? which may be indicative of an increasing linear trend. Each year kasi, nung prinat natin kanina to, di ba? Over time, from 1949, okay, so hanggang 1960, di ba the trend seems to be going up each year. No? So this validates this statement. Increase over time with each year. So it's indicative of an increasing linear trend. Perhaps due to the increasing demand for flight travel and commercialization of airlines in that period. So dito na uso yata yung na-commercialize na yung mga airlines no 1949 to 1960. Okay? In the box plot, there are more passengers traveling in months 6 to 9. So we observe this, no? 6 to 9, dito yung peak. Okay, June, July, August. Dito yung pinaka-peak months natin, no? Okay, ang pinaka-lean dito sa November. November, February, mukhang siya yung lean months. No? So, more passengers traveling 6 to 9. Okay. Then, higher yung variances nila. Paano natin nakita yung higher yung variances? Yung spread, no? This is the median. Okay. Nakita natin yung spread, yung laki ng box plot natin. Okay, the higher the height of the box plot, the higher is its variation. Kasi malaki yung difference ng maximum point niya at saka ng minimum point. Okay? Ganun ba? So, Pierre, may comment dito sa Pierre, ano? Tama lang. Pierre, pakishare nga yung comment mo and then maybe let's get the opinion also of the rest. Here, kindly share your comment. Ay, kanina ba yan? Yeah. About the pace. Okay. Pero sabi mo rin dito, mas maganda kung complete na yung codes. But in some lectures, guys, I'll leave the codes blank, no? Kasi I'm going to ask you to write it. Of course, i-discuss din naman natin. Kasi I noticed, guys, na kapag hindi kayo nagsusulat ng code, mas lesser yung yung appreciation, mas lesser yung mastery ng It's also important for you to be writing the code yourself. Kasi mas nakakatulong yan, mas na-appreciate yung yung lesson. Okay. All right. So, let's move on, guys. Sabi natin, okay, air passenger seems to be multiplicative time series as the passenger numbers increase. So, dalawang klaseng seasonality, guys, yung additive at saka multiplicative. Anong difference ng additive at saka multiplicative? Ang difference, guys, ng additive, pag additive, guys, yung peaks and troughs niya, guys, medyo constant yung constant yung variance. So let me draw that. So this is an example of an additive seasonality. Okay, so kunyari ganito yung data natin, no? May trend siya na tumataas. Tumataas siya, may trend, may seasonality din, no? May mga peaks siya. Peaks at saka troughs tayo dito. But the difference between the high points and the low points seem to be constant. Okay? That's what we call an additive seasonality. Okay, pag multiplicative seasonality, guys, the difference, guys, so may trend tayo dito. Tapos if you notice, so na lang. Okay, what do you notice about the difference in the peaks and the troughs? It's increasing over time. So parang ganito yung nagiging ganito yung range niya, no? Ito constant lang yung variation niya, no? While this one seems to it has a fanning effect, no? So for that, guys, we have pag ganito yung seasonality, it's what we call multiplicative seasonality. Okay? Doon naman sa isa, additive seasonality. That's why ang comment here is that there seems to be, okay, seasonality, tapos sabi, air passengers appear to be multiplicative time series, no? As the air passengers increase, also the pattern also that's the pattern of seasonality. So makikita natin yan, no? Multiplicative siya kasi yung seasonality natin, it seems to be increasing over time. Okay? There do not appear to be any outliers. There are no missing values. Okay? So kita naman natin dito, guys, walang points outside here, no? Sa IQR natin, okay? Walang mga points outside this. Kasi pag may mga points diyan, ibig sabihin outside yun yung sa interquartile range natin, okay? Yung whisker natin dito. Okay, and wala namang mga outliers. All right. Now, one of the very powerful functions in understanding time series is the decompose function. Tingnan nga natin kung saan nanggaling yung decompose na yan. Okay. Question mark, decompose. Okay, saan galing yung function of decompose niya? So this is coming from the stats package. And what does the decompose function does? What does it do? It decomposes a time series into seasonal, trend, and yung hindi ma-explain, ang tawag doon, irregular components. Okay? So yung decompose function allows us to see the trend, the seasonality, and then the irregular component. Okay? So before we run this, guys, we'll try to see if it's additive or multiplicative. Ang additive, ang equation niya, the time series can be defined by the trend, the seasonality, and the irregular time series. Okay? Pag multiplicative naman, it's the trend times the seasonality times the irregular component. Okay? So let's do the decompose function coming from the stats function. Again, guys, hindi natin linode si stats, no? Hindi natin in-install si stats as a package. Wala dito. Pero si stats package is already loaded with the base R. So kahit natin hindi siya in-install, kahit natin hindi require siya, mararan pa rin to, no? Okay, so be mindful of that, guys, no? Pero may mga packages that do not come with the base R. So you cannot run that function coming from that package unless you install that package. Just like kanina yung describe, di ba? Yung describe galing sa site package. Some of you who were not able to install the site package was not able to run the describe function. So kailangan natin i-install yung site package for you to be able to run the describe function. Pero itong decompose na to, guys, hindi naman natin in-install si stats package. But it already comes with the base R. So let's run this. Let's run this too. So we're creating an object called decompose AP additive. Okay? So yun lang pinangalan natin. Decompose air passenger additive. So we're using decompose function, yung AP object, and then additive. And then i-autoplot natin. Okay, so let's run this first. Control Enter. Okay. So what can you find here, guys? So the decompose function gives us now the components of our time series. Ito yung data natin, no? Okay, sige, let's see. Let me show this in a bigger screen. Okay. Okay, so we have the data here, the original data. Okay. And then you notice that it was decomposed into ito yung linear trend niya, no? So pag ganun yung trend niya. Okay, what else? Ito yung seasonality niya, no? Seasonality niya ito. And then yung hindi kayang i-explain ng trend at saka seasonality, yun yung remainder. That's the irregular component. So if you can see this one, guys. So mukhang wala nang pattern, ano? Kasi kung may pattern pa yan, ibig sabihin may kulang pa tayo dito sa seasonality natin at saka sa trend natin. Okay, dapat yung irregular component, dapat wala nang pattern yan, guys. No? Okay, so that's your additive. Okay, let's now take a look at the multiplicative. So let's run this. Let's call it decompose AP mult. And then this time, we're using the multiplicative. Okay, so and then i-autoplot natin siya. Okay. So, hindi rin masyadong apparent dito, guys, no? Okay, this one is your trend. This one is your multiplicative seasonality. Okay? And this one is your remainder. So, halos pareho lang siya. Ibig sabihin, hindi masyado nagkakalayo itong models na to. Okay. All right. So the decompose function allows us to see, guys, lalo na kung may seasonality, maganda tong pagmo-model na to. All right. Okay. So whenever we model, guys, pag nagmo-model tayo ng time series, ang gagamitin natin for this subject is the very popular and the very powerful Box-Jenkins approach. Si Box-Jenkins approach, Box and Jenkins, sulat ko yun. Box and Jenkins. Okay, there were the ones, guys, who started or who developed the ARIMA model. Okay, ARIMA. What does ARIMA mean? Anyway, anyone, guys? Ano ibig sabihin ng ARIMA? Pwede kanyong i-unmute yourself. Sigurado kayo, guys, yung mga students ko sa FinStar, hindi natin na-discuss to. Are you sure? Sino ba estudyante ko dito sa FinStar? Sige nga. Josh, Bern, were you my student in FinStar?
Sir, FinStad lang po.
FinStad. Kaya pala. So, sino FinStar mo?
Sir Rene Cuartero po.
Si Sir Rene. Okay. Kaya pala. Nagtataka ako guys kasi ang alam ko, guys, yung mga nag-FinStar sa akin, ilang beses natin diniscuss to eh. Okay? So, who among you were my student in FinStar? Honest, guys, kasi tatanungin ko kayo. Melanie, ikaw hindi ba?
Sir, FinStad lang din po.
FinStad din? Okay. Sige. Hindi nyo na-discuss yung time series sa FinStar nyo? Paki-chat nga please kung yes or no para alam ko kung paano yung pacing natin dito. Kasi kung hindi, sabi nyo kasi kanina hindi eh. So I'll be more deliberate and hindi ko pa pwedeng i-madaliin, no? Kasi kung if you were my students before, medyo mas paspasan tayo dito kasi na-discussan natin to in the past eh. Guys? So hindi nyo na-discuss yung ARIMA.
Hindi po, sir.
Okay, sige. All right, thank you for your feedback, okay? So, at least good yun kasi ibig sabihin nun, matatapos tong term na to na hindi na tayo ignorant of what ARIMA is, no? Okay, but that's very good. Then I will have to adjust how I pace myself. Okay, so medyo magpo-fundamentals din tayo, no? So when we talk about ARIMA, which begs, by the way guys, medyo mag-research din kayo, magbasa din kayo ng what ARIMA is, okay? And then how do you write the equation? Kasi importante 'yon. Kasi itong subject na to, guys, actually it's a conglomeration of different topics in finance na supposedly dapat na discuss na before, no? So dapat na napag-aralan na before, no? But since hindi pa, it's okay, guys. So when we talk of ARIMA, guys, dinevelop to ni Clyde Box and Clyde Jenkins ba? Kalimutan ko yung first names nila. But these are two people, Box and Jenkins. Sila nag-develop, guys, ng ARIMA methodology as far as forecasting or modeling time series. Okay, and sabi nga ni Clyde dito, I think it was Clyde. Si Clyde nag-chat, sabi niya, ang ARIMA is, okay, si Jillian pala, no? Jillian, thank you. Sabi ni Jillian, ang ARIMA is autoregressive, integrated moving average. Okay? So this is a powerful method. No? Ngayon, ginagamit pa rin yan. And kaya nga, sa R guys, ang dali-dali nang gawin ng ARIMA. Kwentuhan ko lang kayo, nung nagta-time series ako dati several years ago, no? Dekada na yata, wala kaming R. No? Ang ginagamit pa namin nun, e-views. And hindi basta-basta namin ma-generate yung model. Aaralin talaga namin, magpa-plot kami. Ang daming ang dami naming tinitinan muna bago namin ma-decide kung ano yung model namin. No? So, you're very lucky guys. You're very fortunate because you can already use R itself, R Studio, in order to define the model itself ng ano. We will be able to use yung auto-arima. Okay? Mamaya titingnan natin auto-arima guys. So what's the purpose of this? Okay, ang purpose natin ito guys, paano natin mamomodel to? Ito yung time series natin. No? Paano natin mapipredict? Kunyari, pinapredict sa atin, pina-forecast natin yung next 3 months. Kasi monthly data to. O next 6 months. Okay, or next 1 year. Although sa forecasting, hindi maganda yung nagpo-forecast tayo ng too long in the horizon. No? Magiging very prone to error na yon. Okay? So how in the world are we able to model this? Okay? So yun ang isang topic ng forecasting. And that can be done using the Box-Jenkins approach of ARIMA, which means autoregressive integrated moving average. So ko lang isulat ko lang dito guys. Okay, for our ang problema ko dito hindi na ako makapunta sa next page kung ayan, okay, yan, good. Okay, so this is ARIMA, no? ARIMA. So this one is autoregressive. Autoregressive. Tapos yung isa, it's MA. So this is moving average. Moving average. And then there's this I here. And ginagamit to guys, ang tawag dito integrated. Okay? So, as your assignment guys, mag-research kayo kung ano tong ARIMA na to, no? Yung model niya. Okay, suffice it to say at the moment that when you say autoregressive, guys, we are trying to model y sub t, this is our time series, no? Y sub t is equal to a certain constant alpha, okay, plus alpha 1, okay, times y sub t minus 1 plus a certain error term. Okay, take a look at this model, guys. Paano natin minomodel yung time series natin? This is our time series. Here, we're modeling the time series using, what's y sub t minus 1? Anyone, guys? What is y sub t minus 1? Paki-check nga please kung ano yung y sub t minus 1. What's this, guys? O kunyari guys, may time series tayo 10. Like, gamitin natin yung natin. Gamitin natin yung data natin. Yung AP. Let's use our AP, guys. Okay. Ito yung AP natin, no? Here. This is our AP. Yan. So, this is our Y sub T series. Okay? So, if we put an index here, this is 1, 2, 3, 4, 5, 6. No? Now, our Y sub T is, okay. Y sub T natin, baliktad to no? Ito yung latest, no? 432. So, this is your Y sub T. This now is your Y sub T minus 1. Yung previous value. Okay? So, when you take a look at this value, 407, yung Y sub T minus 1 niya will be 463. So Y sub T minus 1 is the previous value. Okay? Guys, kuha nyo, guys. Intindihan ba yung Y sub T minus 1? Pakichat naman please kung naintindihan anong ibig sabihin ng y sub t minus 1. Okay, thank you. So, what does this tell us? We're modeling, pag binomodel natin si y sub t, ginagamit natin yung previous value niya. Okay? So we're modeling y sub t in order to predict y sub t. Kunyari, how do you predict y54, which is the 54th data point? It's equal to alpha sub o plus alpha 1 times y sub 55. Yung value niya, yung previous ano niya, yung previous year 54 pala, no? Y54, assuming that 1 is the first, yung earliest value. Gets you guys? So this is what we call autoregressive. Bakit auto? Auto means, guys, self. Autobiography, no? Self yan. So in other words, guys, we are regressing. We're creating the model based on values of itself. See, guys, past value. In fact, ang tawag na to, guys, sa model na to, AR1. AR1. This is an autoregressive 1 model. Ano kung AR2 naman? So ang AR2 naman, AR2, okay, we are using 2 past values. Okay, so our model will look like y sub t is equal to alpha o plus alpha 1 times y sub t minus 1 plus alpha 2 times y sub t minus 2 plus a certain error term. Yun. So that's an AR2 process. No? AR2 process. Kasi we're using 2 lags of previous values, y sub t minus 1 and y sub t minus 2. Of course, multiplied by a certain constant. No? Okay, so that's the autoregressive process. As the name suggests, auto, self, regressive. We're regressing the variable, the time series, into past values of itself. Okay, ano naman yung MA? Anyone, please? Kindly check, guys. Ano yung MA? Anong ginagamit natin to regress the time series? Pakicheck, guys, sa internet. Mag-check kayo ngayon. Ano yung MA series? Okay, ano ibig sabihin ng MA1 series? What's MA1? Anyone?
Moving average po, sir.
Yes, moving average. Pero pag moving average, ano yung minomodel natin? How will your model look like? Okay, sige, sulat natin dito ha. Okay. So na-identify na natin si AR1, di ba? Ano naman to? Sandali ha. Ang hirap ang hirap mag-move up. Ay, you know. This is the problem that I encounter whenever I'm using. Okay, anyway. I'm just going to use another. Okay, so we were able to define already an AR1 process, no? Okay, kasi kailangan, guys, intindihan natin to ha. An AR1 process, autoregressive, we're modeling, we're trying to predict the value of a time series. Kunyari, y sub t map plus 1, kunyari, no? So gusto natin i-predict yung value niya 1 year from now, and we're going to model, this is a constant, alpha 1, y sub t, no? Plus a certain error term. So, pareho lang yan, guys, sa y sub t, alpha o plus alpha 1, y sub t minus 1, plus epsilon sub t. Okay. Diba? So here we're modeling the series based on past values of itself. Eh yung MA, guys, ano yun? Ano yung MA1? How are we modeling the series? Y sub t is equal to alpha o plus what? plus, anyone please? Yes, moving average to. Pero ano yung model natin? Ano yung moving average na model? Anyone please? Ang laki ng internet, guys. Ano yung MA1 process? Ano yung equation nun? Somebody please? Somebody please, guys? Hello, guys. Check nyo, guys. Okay? Sige. All right. W ba nakita mo, Bern? MA1 process?
Opo, W po nakita ko sa Google.
Okay, sige. Iba pa, guys. Tingnan nyo pa. Lagay nyo AR, gawin yung ARMA 11. Okay, as I was saying, guys, find the equation for an ARMA 11 process. So itong process na to, guys, combination, no? Combination ng autoregressive at saka moving average. Order 1 ng AR, ibig sabihin log 1 ng AR process at saka log 1 ng MA process. Sigurado kang W. Yung ano, yung MA1 process, Burn. Hindi epsilon yung ginamit. So usually epsilon yung ginagamit eh.
Sinerch ko lang po talaga MA1 tapos process lang po. Baka mali lang.
Hindi sa parang baka hindi sa ARIMA model yan. No? Okay, how about the rest, guys? Come on, guys. Tell me the function for ARMA 11. Talaga mapa ito. Mababa siya pag ina-arrow down ko naman. Ayaw. Page down ba? Okay, anyone, guys? Guys, we're running out of time. Okay, nagbigay dito ng equation si David, no? Okay. So guys, sino yung equation na binigay ni David? No? Copy ko siya. Ayaw mag-ano. All right, let's see this. So, ano equation to? David, ano equation to? Anong model to? David? Yeah. Correct. This is ARMA 11. Bakit naging ARMA 11 siya? Okay. Bakit siya naging ARMA 11, guys? ARMA 11 siya, guys, kasi look, how are we modeling? Yung time series natin dito si XT, no? And yung Z natin dito, these are your Okay, these are your error terms. Ang iba, usually ginagamit dito, epsilon to denote it by error term. Okay, gamitin natin si epsilon. Symbol, okay, epsilon. Okay, there. Para medyo mas consistent tayo. Okay. Tapos ito. Okay, home. Let's see. Yan. Okay. Let me explain this to you guys, no? Okay. So sinabay na natin ARMA 11 according to David, no? Ito ARMA 11 model yan. Bakit siya naging ARMA 11? Okay, so let me rewrite this. Copy natin dito. Okay. This can be rewritten as, pwede natin i-write to as. So I'm going to move this to the other side, no? So yung equal dito, ilalagay ko dito. Ilalagay ko yung equal dito. Yan. Ditang ko. Okay. So we're modeling here plus. Okay, we're modeling here x sub t. This is our time series. Now, what did we use in order to model our time series? What's x sub t minus 1, guys? What's x sub t minus 1? Diba x sub t minus 1 is past value of x sub t. T minus 1, the previous value. So what process is this? This is an AR1 process, guys. Diba? We're using the past value of our variable x, our time series, in order to model x sub t. Okay. Anong order ng log? 1 lang. Kasi pag x may x sub t minus 2 pa, magiging ARMA 2 na yan. No? Kasi 2 orders, 2 logs. Okay, I hope you're getting me, guys. And then plus, okay, take note, guys, that we're using epsilon is the error term. Kanina ang ginamit z. No? This is the error term. So minomodel natin si x sub t using the past error terms. Okay, so take a look at this, guys. Epsilon sub t minus 1 and x sub t minus 1. So both were using the autoregressive. Autoregressive to kasi past values of itself and past values of error terms. This is the MA model, guys. Yun. So this is the MA component. Ito. Ito yung MA component, no? Ito yung AR component. Anong order to? Isa lang. Past value of 1 order lang. Ito din, anong order nito? Isa lang din. So MA1 component to. So pag pinagsama natin to, this is called an ARMA 11 process. Okay? So, ganun lang yung guys, no? Ang ARIMA, guys, ang ARIMA o ARMA muna, saka ko na i-explain yung ARIMA. Ang ARMA process, guys, is you use the past values of the series and the past error terms of the series. So pag sinabing ARMA 2.1, ano ibig sabihin ng ARMA 2.1? Ibig sabihin nun, ARMA 2.1, order 2 ng AR process, at saka order 1 ng MA process. Ibig sabihin nun, guys, yung equation na to mababago, magkakaroon ng, so phi1 to, no? Magkakaroon pa ng plus phi2 times x sub t minus 2. Okay? Plus ito na, no? Plus yung t minus 1. Ito laging meron, no? Laging may epsilon sub t. Okay? So that's an ARMA 2.1 process. Of course, pag ARMA 2.2 process, madadagdagan ng theta 1, epsilon t minus 1, and theta 2, epsilon t minus 2. Okay? Kasi dalawang logs Dalawang period ng lunch ng error term siya. Okay, pause muna ako guys. Question ba dun sa distinction ng AR1, AR process, MA process? AR1 guys, AR process makes use of past values of the series itself. Okay? Kung X yan o Y yan, gagamitin natin yung past values ng niya mismo. Kaya nga dito kasi ang tinawag na yung series natin dito X. So gagamitin natin yung past values ni X. So that's your AR component. Yung MA component naman, past error terms. Ito, isang order ng error term, so MA1 yan. Kung dalawa yan, T-2, MA2 yan. Pag pinagsama mo yung dalawang yan, guys, you call it an ARMA process. Okay. Pause ako guys, clear ba so far? Okay. Hindi naman siya mahirap intindihan guys. Basta tandaan natin, autoregressive. Auto, self. Regressive, we are modeling, we are regressing the value of the time series by itself. Okay? Pag MA naman, moving average, ang ginagamit natin yung error terms niya. Okay, paki-chat nga guys so far kung clear yan. Clear so far guys yung meaning ng AR, yung ARIMA natin. Although hindi ko pa na-discuss yung integrated, no? Hello? Kamusta guys? Pa-feedback naman kung clear so far. Okay, yeah. That's correct, Bern, no? Tama 'yan. Guys, kasi hindi naman natin makukuha lahat sa sitting na saan na to, no? Sa session na to. It's a good way to learn, guys. Self-study din, no? So tama si Bern. Thank you Bern for that, no? To supplement the discussion today. Okay, so recapitulate ko lang guys, ha. Okay, just to summarize this. Hindi ko talaga makuha yung technique nito, no? Hindi ko malaman kung paano. Nahihirapan ako lagi dito guys. Pag ine-enter ko, bumababa na siya. So just to recapitulate guys, AR process. Ano yung AR guys? Autoregressive. So pag sinabi mo autoregressive, gagamitin natin, auto is self eh. Gagamitin natin yung values niya mismo. Kung ang series mo y sub t, gamitin mo yung y sub t din. Okay? Kaso past values niya. Okay? So this is order 1 kasi 1 lang eh. 1 lang yung past value na ginamit mo. Kung past 2 values, then AR2 process yun. Okay, kasi you're using 2 previous values, no, to model your time series. Yung MA naman guys, MA, moving average, okay? So ang ginagamit natin dito yung error terms, yung epsilon. Yung error terms ng model natin. So MA1 means you're using the past error term, epsilon t-1. So usually ang ano nito, ang parameter ang tinatawag theta. No? Pag dalawa guys, then magdadalawa tayo. Theta 2, epsilon t-2. Okay? Of course, ina-add lagi natin yung epsilon sub t. Laging kasama to. This one. Okay? Alright, summary lang yan guys. At least medyo may idea na tayo na ganun pala yung ARMA process, no? Hindi ko pa dinidiscuss yung ARMA process. So pag ARMA process according to Box and Jenkins, gamitin natin yung past values niya. That's the AR component. MA naman, past error terms, past residuals. Okay? So sige, tuloy natin, no? Now, when we use, okay, saan na tayo? Okay, air passengers. Now, for us to be able to use Box Jenkins, yung ARIMA model, dapat guys, yung series natin should be stationary. Okay. Sige nga, paki-check nga guys sa internet. Anong ibig sabihin ng stationary data? Okay? Very important guys na stationary yung data natin. For us to be able to model using ARMA. Okay, ba't natin gagamitin yung ARMA model guys? Kasi napaka-powerful ng ARMA. We're using past values of itself and past error terms. So, very powerful yung model na yan. Pero para natin magamit yung ARMA guys, kailangan yung data natin stationary. Ito, no? Stationary of the time series. Now, ang question, ano ibig sabihin ng stationary? Sige nga, guys, as an exercise, kindly search for that in the internet. Anong ibig sabihin ng stationary data or stationary time series? When is a data stationary? I'm waiting for your chat, guys. I'm waiting for your answer. So that's one other item na dapat natin malaman, no? Stationary. Gusto natin magamit si ARMA, no? Gusto natin ma-model yung time series natin using the ARMA process. Ano ba yun? AR1 ba yan? AR21 ba yan? ARMA 21 ba yan? Anyone, guys? Okay, let's contribute to the discussion. Ano daw yung stationary time series? When is a time series stationary? Ano yung mga what are the attributes, what are the qualities? Visually guys, madali makita eh. Pag stationary yung data natin. For example, ito. Outrightly sasabihin ko guys, yung AP natin, yung AP series. Ito. Hindi stationary yan. This is not stationary. Kaya outright, hindi natin pwede kagad magamit yung AR process natin. Yeah, sige, may nag-answer? Yes, okay. Jillian, correct. One answer is that a stationary data series has no trend. Oh, ito lang, may trend na kagad eh. Di ba? Ano pa? Aside from no trend ang stationary, okay, ano pa? Yan, sige, let's see. Hesed, could you unmute yourself and paki-ano nga? Paki-Hesed, paki-share yung answer mo sa ano? Sa class?
Yes, sir. A stationary time series is one whose property do not depend on the time at which the series is observed.
Okay. So, hindi siya affected by time nor seasonality, no? Ganun din yun. Pareho lang yan. So, ibig sabihin, hindi siya dependent dun sa previous time. Hindi rin siya dependent dun sa seasonality. Wala siyang trend. Pag hindi siya dependent on time, guys, ibig sabihin walang trend yun. So, based on this definition, of course, may mga formal definition pa, no? Which I want you to look into. Okay, so assignment nyo yan. Tingnan nyo yung ARMA process, yung stationary. Ito ba stationary to, guys? Answer, please. Is this a stationary data series? No, tama. Hindi stationary, no? So, pag gagamitin natin guys yung ARMA model for this, we will have to convert this first. Hindi kasi pwedeng mag-ARMA model guys kung stationary, kung hindi stationary. There's a trend, there's seasonality, no? Kitang-kita, no? So, ibig sabihin nun, itong value na to, siguro July to, no? Nagdi-depend siya sa past July value. Okay? So, may dependence yung mga ano natin, yung mga values natin. They were dependent on past year's value. So this is definitely not stationary. May trend na, okay, meron pang seasonality. Ang stationary data series, guys, parang ganito. Parang ganito, yan, no? Ito. Ayan. Take a look at this, yung remainder, yung irregular component. Yan, parang stationary yan, di ba? Okay? Right? Ito may seasonality kasi, kaya hindi din stationary yan. Okay, how do we determine, guys, whether a data series or time series is stationary or not? Aside from visual, to kitang-kita naman visual, there are formal statistical tests in order to determine if our data is stationary or not. Okay, so unang-una, guys, ito yung ADF test. This is your augmented Dickey-Fuller. Okay, sulat ko ha, augmented Dickey-Fuller test. Okay? Augmented Dickey Fuller test, ADF test. So this ADF test is from the package T series. So dapat na install niyo yung ano na to, ilagay ko yung namesake niyan, yung T series, no? Okay. So what does the ADF test give us? Ilagay nga natin dito. Question mark ADF.test. Okay. Yan. Okay, let's see. ADF.test, yan, no? This is from the T series package. Augmented Dickey Fuller. Okay? Computes the augmented Dickey Fuller test for the null that X has a unit root. Okay, yan. Ano ibig sabihin ng unit root? Okay, that will be another assignment, guys. May mga terminologies sa time series na dapat alam natin. Okay? So, kasama na dun yung ARMA, okay? Yung concept ng stationary at saka yung unit root. So as part of your assignment, guys, I want you to read up on this. Okay? Research na lang. Ano ba ibig sabihin ng unit root? Okay. Ito ibig sabihin, guys, no? Ang null hypothesis natin dito, take a look at this, is that the series, the time series is non-stationary. Okay? So ang gusto natin, guys, we want this to be rejected. Okay? We want this to be rejected kasi gusto natin yung series natin stationary. Okay? So this is the null hypothesis. And the syntax here is that ADF.test, yung data natin AP, and ang alternative natin stationary, and then isasama natin yung cycle niya, yung frequency, yung ano niya, K is equal to 12. Okay, so let's run this. Run natin. Okay. Okay. What do we have here? Augmented Dickey Fuller test for the data AP. Okay, p-value 0.7807. Okay, what did you learn in your FinStar? If the p-value, and normally ang ginagamit is confidence interval, no? Level of significance level natin is 0.05. If the p-value is 0.78, what is our conclusion, guys? What's our inference? Should we fail to reject the null hypothesis or reject the null hypothesis? Answer? Sana everyone, guys, ha, dapat alam nyo na yan, no? Nag-FinStar na kayo. P-value daw 0.7878 ng ADF test natin. So anong conclusion natin? Fail to reject the null hypothesis or reject the null hypothesis? Anyone? Anyone, please? So gagamitin talaga natin dito yung FinStar natin, no? Hello? Anyone, please? I was expecting automatic na yung answer natin dito. Okay, may nag-chat. Reject, Jillian. But reject? Di ba, guys, ang general rule, when the P is low, ewan ko kung na-discuss inyo to, no? When the P is low, the null must go. Okay, ito yung tinuturo ko sa mga students ko, no? When the P is low, the null must go. Okay. Anong low dito? Usually, ang significance level natin 0.05, no? Okay. If the P is less than 0.05, then we reject the null hypothesis. Okay, so ang sabi ni Jillian, fail to reject. Bakit? Jillian, binago mo yung answer mo. Jillian, share mo naman yung answer mo sa sa class. Okay, Jillian, can you unmute yourself? Ano talaga? Reject or fail to reject?
Fail to reject po, sir.
Fail to reject. Oh. Kasi, di ba? When the P is low, the null must go. Ano ba yung P natin? Is the P less than 0.05? Hindi. So, we cannot reject the null. Ibig sabihin the null must go, we reject the null hypothesis. So dito, since P is greater than 0.05, we fail to reject the null hypothesis. Ano ba yung null hypothesis natin? Ano yung tinetest natin? The time series is non-stationary. Okay, tama kaya yung conclusion? Okay, ito yung series natin. Stationary ba to o non-stationary? Guys, everyone answer please. Is this time series stationary or non-stationary?
Hindi po.
Hindi stationary, di ba? May trend, di ba? So, pinormalize lang natin, guys. Pinormalize lang natin yung conclusion natin kung ano siya, kung stationary o hindi. And according to this statistical test, yung augmented decoupler, okay, sinasabi niya, oops, hindi stationary yung data. No? Your data is not stationary based on this null hypothesis. Okay? It's already time, guys, na ito na lang we'll just end in this, no? Okay. Now, another part of your of what you have to learn, guys, is itong ACF, okay, at saka itong PACF. Okay? Ano yung ACF? ACF is autocorrelation function. Autocorrelation function. And this PACF is partial autocorrelation. Unfortunately, guys, in time series kailangan natin malaman to. Pero buti nga lang, guys, ngayon hindi na masyadong mahirap intindihin tong ACF at saka PACF. Kasi dati ginagamit yung ACF, PACF para malaman kung anong model 'yan. AR1 ba 'yan, MA1 ba 'yan, or whatever, no? Ngayon, guys, hindi na. Kasi even without looking at the ACF, PACF, pwede natin gamitin, guys, yung itong auto.rima function, no? Ni R para malaman natin kung ano model. Okay, quickly, guys. May I have just 2 minutes? May permission ba ako sa inyo ng 2 minutes, guys? Pa-chat naman kung yes or no. Pag mag-no kayo, guys, magtatampo ko. Joke lang, guys, joke lang. Yan, sige. Thank you. Sige, 2 minutes lang ha. Okay. Anong ginagawa natin dito? Dito, sinasabi natin kay R, paki-plot mo nga yung autocorrelation function. At saka dito, paki-plot mo nga yung PACF. Okay, sige. I-run natin to. Okay? Ang pinapaplot natin yung ACF ng object natin na AP, pati yung PACF ni AP. Run natin pareho. Let's run both of them. And here, you have the PACF and the ACF. Okay? ACF and the PACF. Now, next meeting, alamin natin anong ibig sabihin nito. General lang hindi na natin titingnan yung mga nitty-gritty details nito. Suffice it to say, guys, na ang ACF ginagamit yan para malaman kung there's this presence of an MA model. Ito namang PACF ginagamit yan para malaman natin kung may presence siya ng AR model. No? ACF to determine, meron bang MA dito? May MA component ba yung model natin? PACF, may AR component ba yung model natin? Yan ang gamit niyan. Okay. So, ito pareho lang, guys. Parehong plot lang. Let's run this. Ganun din, no? Ito yung ACF natin. Ito yung PACF natin. Lastly, ito. Lastly, guys. Now, the beauty about this, guys, is dati, pag nagmo-modeling kami nito, guys, oras-oras yan. Kasi magpa-plot ka ng PACF ACF at saka PACF. Tapos dito malalaman mo, katulad nito, pag ganyan, guys, yung behavior nito na may seasonality, okay, medyo indicative to na AR process to. AR process. Tapos ito may spikes pa, mukhang AR process to, no? Okay, but I'm just guessing, no? I'm just guessing. Malamang may AR component to. Kasi ang AR, guys, ang AR component may exponentially decaying yung niya, ACF, tapos yung PA niya, mga spikes. Opposite naman yung MA model. Sa MA model, spikes dun sa ACF, although may mga spikes dito, tapos yung PACF niya, smooth decay. No? Alright, so the good thing about this is that we can now identify the model using auto.rima. Imagine, guys, umaabot kami ng just one time series. Dati, ilang oras yun para makapag-come up lang kami ng model. Ito, guys, sa R, tingnan nyo. Run. Ayan. Run na natin. Tapos ito na, sasabihin na niya kung anong model yan. No? Ayan, guys. So, ang sinasabi niya, it's an ARIMA. Yan, ARIMA model. No? I-discuss natin to next meeting. Okay? Merong AR1 component, may AR2 component, at saka may AMA component. Yan ay model natin. So, we will regress the time series by its past log1 value and past log 2 values, and pass one log error terminal. That's it, guys. That's it. Okay. So thank you so much, guys. I'll stop recording first. Okay. Stop.